In this video, we will show you how to perform ultra-rapid freezing of solid tissue. Cryopreservation is a good method for slowing the activity of cellular pathways in biological tissues, thus preventing nucleic acid and protein degradation. Frozen tissue biospecimens can be stabilized for subsequent sectioning on a cryostat for biochemical or genetic investigations. There are various methods and materials used for cryopreservation. Here we will describe ultra-rapid freezing of solid tissues inside cryomolds with a cryo-embedding compound using either cooled isopentane or vapor nitrogen. Because these procedures for freezing tissue biospecimens requires working with dangerous materials, we use personal protective equipment such as a lab coat, closed-toed shoes, lab gloves, cryo gloves, as well as safety glasses when necessary to avoid splashes to the eyes. Several of the materials used in these cryopreservation methods are hazardous, and the appropriate safety precautions should be taken. Liquid nitrogen is extremely cold at negative 196 degrees Celsius and will instantly freeze exposed skin upon contact. It should only be used in appropriate shatterproof vented containers. It will boil when placed into a warm container and may splash. At a minimum, wear cryo gloves, a lab coat, and eye protection when working with liquid nitrogen. Isopentane or 2-methylbutane is a highly flammable liquid with a boiling point of 28 degrees Celsius and should be handled inside a fume hood. When cooled with liquid nitrogen, this liquid will reach negative 150 degrees Celsius, and so the same precautions for handling this cold material will apply. Dry ice or solid carbon dioxide should be handled with cryo gloves as its temperature is near negative 80 degrees Celsius and can cause frostbite when handled without protection. Now we'll discuss the steps involved in preparing tissue for cryopreservation. Obtain all your supplies including cryomolds, printed labels, cryo-embedding compound, forceps, scalpels and blades, and towels to use as a clean work surface. Tissues should be prepared and stored as soon as possible and held on wet ice until storage is accomplished. Place the biospecimen label onto the cryomold. Make sure the pre-printed labels are specific for ultra-low temperatures. Any handwritten labeling should also be solvent resistant. Use clean forceps, blades, and work surfaces for each tissue biospecimen you're handling to avoid cross-contamination. If the tissues are wet or bloody, blot them on a lint-free towel. Placing a small amount of compound in the cryomold will help the tissue adhere directly to the bottom and replace any air gaps between the tissue and the mold. Ensure the tissue fits comfortably in the cryomold with space between the tissue and the cryomold edges. These cryomolds are 5 mm deep, so the tissue should be no more than 5 mm in thickness. Place the tissue into the cryomold over the compound with the side of interest facing down. Cover the tissue with compound on the sides and fill the mold to completely cover the top of the tissue. If you create any air bubbles, remove those that lie near the tissue. The tissue is now ready for ultra-rapid freezing. To freeze tissue with liquid nitrogen-cooled isopentane, prepare your supplies inside the fume hood. These will include an insulated container with liquid nitrogen, a metal container with isopentane, and a metal holder or large forceps to hold the tissue while freezing. Also have an insulated container with dry ice nearby to hold the tissue once it has been frozen and until it is ready for storage. A large ice bucket will be filled with several centimeters of liquid nitrogen. Place a smaller metal container containing a few centimeters of isopentane inside the bucket. The placement of the isopentane into the liquid nitrogen bath will cause the liquid nitrogen to boil until the isopentane container begins to cool. As the isopentane cools, small bits of solid isopentane will begin to form at the bottom or edges of the container. This is a good indicator that the temperature of the isopentane is now ideal for freezing tissue. With large forceps holding the edges of the cryomold, partially immerse the cryomold into the cooled isopentane. We choose not to fully immerse the cryomold into the isopentane, but some procedures do call for this. The embedding compound will turn an opaque white as it freezes and solidifies, until it is finally a crisp white color. Keep the cryomold in a container of dry ice until the tissue can be wrapped and stored in a freezer. Another method for ultra-rapid freezing of tissue is using a liquid nitrogen-charged vapor dewar. The dewar is prepared in advance by adding up to several liters of liquid nitrogen. The hydrophobic absorbent material inside the Dewar walls absorb all the liquid in approximately 12 hours and provides an inner channel of nitrogen vapor at approximately negative 150 degrees Celsius that can maintain its temperature for 7 to 10 days. The Dewar has an inner sleeve for sample storage. This unit displays a shelving rack custom-made to fit in the sleeve and provide multiple shelves for storage. The Dewar provides a portable, easy-to-use freezing apparatus. With the tissue prepared in the cryomold, remove the sleeve from inside the Dewar. Remove the rack from the sleeve. Place the cryomold onto the rack and replace the rack into the sleeve and back into the Dewar. The tissues will be frozen in 60 to 90 seconds. The frozen tissue blocks are then specially wrapped in parafilm and foil. This will help to keep the block airtight to improve long-term storage. A strip of parafilm is stretched and wrapped several times tightly around each block. Then the block is wrapped with a piece of aluminum foil. The blocks are then labeled and stored in cryo boxes for final storage in liquid nitrogen freezers.